Hi, welcome back to the channel. And just in case you are new to the content on this channel, consider subscribing and ring the notification bell so that each time we upload new content, you're going to get the notification. We have a lot of exciting content that is coming up, so consider subscribing. Okay, um, so this video just marks as an introduction to us talking about the Laplace transform. Okay, the Laplace transforms. So I'm just going to go through the definition, and I'll briefly talk about other things that have to do with the Laplace transforms, and I'll try to pick some basic transforms that we have to know to make our work much easier as we do a good number of questions where we have to use the Laplace transforms, because it's not every time when you have to use the longer route to arrive at your answer. There are some basic Laplace transforms that we have to know that are going to make our work much easier and interesting. Okay, so I'm going to give what I feel is the most basic definition of what the Laplace transform is. Okay, this is just more like it's a method. Okay, it's a method that we use to solve differential equations. Okay, it's as simple as that. It's a method that we use to solve differential equations, and what we do to those differential equations, we reduce them, we transform them into an algebraic function, or from what they are into an algebraic form. Okay, so the notation the notation for Laplace transform, let's say that function that we want to transform is indicated or is given as f of t. Then if you want to transform this function here, we use this more like squiggle the L like that. Then so it will be like the Laplace transform of f of t. Okay, this is going to be equals to the algebraic function that you're going to get that is indicated as capital F of s. Okay, so this is going to be equals to, so how we transform it is that you're going to be using an improper integral. And by the way, just remind ourselves, when talking about an improper integral is one whereby, let's say you have limits from, let's say, minus infinity to 0, or you have minus infinity to positive infinity, or maybe you have not minus, let me say 0 to positive infinity there. So any of these is what is indicated as an improper integral. So we're going to be using an improper integral, okay, uh, that has the limits from 0 to what? 0 to positive infinity. Okay, so what we'll be doing here is that we are going to be getting our f of t, which is our function f of t. Then we are going to be multiplying it by e to the minus st like that. Then we integrate with respect to t. That's our dt. So this that we have right here, looking at the limits that we have from 0 to infinity, it's very much important that this converges. Okay, if it converges, if it diverges, then we're not really going to get what we want. So for it to converge, it has to be that our s is what? Our s is greater than 0. And keep in mind to say our s is just more like a parameter here. Okay, so what we have right here is what we are going to be doing. So we'll be getting whatever function that we are given here, then multiply it by that, then do the integration here. And again, it's important that we try to remember how to use integration by parts, because it's going to be very, very, very useful when it comes to the Laplace transforms. Okay, so this of course can also be written as you can use a limit where you say uh, the limit as n, let me use n, as n approaches infinity. Then you evaluate the integral from 0 to n. Then you're still going to have your f of t multiplied by e to the minus st. Okay, that is e to the power minus st dt. So this right here is what we are trying to say. Okay, so we should always remember this notation right here. So let me try to give some basic transforms that we have to that we have to know, and they're really going to make our work much easier. And by the way, when you look at what I have right here, it basically means this one here is our this one here is our input. Okay, That's our input, that's going to be our output function there. Okay, so that's more like quite obvious. So let's try to first of all look at what the Laplace transform is for, let's say, f of t equals to 1. Okay, what f of t, the Laplace transform of f of t equals to 1. So how this one is going to be is that you're going to say, okay, we are looking for the Laplace transform of f of t. What is f of t? It's 1. Okay, so this is going to be equals to the integral we evaluate from 0 to positive infinity. Then that would be 1 multiplied by e to the minus st. That's just going to be e to the minus st dt. Okay, so how do we go about this one? So integrating this one is very simple. Okay, it's very simple. So the way it is here is that you are going to write our e to the minus st the way it is. Then you're going to divide this by the derivative of the power with respect to t. So remember that you have minus st. Okay, minus st. If you integrate this, or sorry, if you differentiate that with respect to t, you're going to get minus s. So that will be divided by minus s, but I'll just put the minus there, then I'll put s like that. Okay, but keep in mind you are evaluating from 0 to what? To positive infinity. Okay, so what it is here now is just a matter of substituting for these values here. So you're going to have something like we have like minus e to the minus s multiplied by infinity. Okay, divide by s. That would be then that's supposed to be minus this minus here, but I'm just going to put a plus here. That would be plus e to the minus s multiplied by 0 divide by s like that. So you clearly observe to say this one becomes 0. How does it become 0? I have like e to the minus, this will just be infinity. Okay, e to the minus infinity, which can be written as 1 over e to the infinity, of which this is just 1 over infinity. So you observe that this goes to 0 very fast. Okay, it goes to 0 very fast. So this one just becomes 0 there. So that would be plus what you have here. So now when you look at this one, that is so you observe that here you're going to get a 0, of course, plus this is going to be a 1. How is it going to be a 1? Because you have like e to the power s multiplied by 0. We don't really care what s is, whether it's positive, it's negative, it's big, it's small, it's still going to be a 0. So that would be e to the power 0 divided by s, giving us 1 over s. So now we have determined that the Laplace transform of 1, okay, the Laplace transform of 1 is just nothing but 1 over s. So we really have to know this because you're going to be using it on a good number of questions. Okay, so we have to keep that in mind. So now let's look for the Laplace transform of just a constant number. Let me indicate it using c. Okay, meaning it can be 1 or it can be 2, it can be 3, it can be any number, whether positive or negative. So the way this one is going to be is like this. That would be c there is equals to, so that would be, you are still evaluating from 0 to positive infinity. That would be c multiplied by e to the minus st dt. Keep in mind to say I'm treating c as a constant. It could be anything. So I'm just going to put c there, then like that. That would be e to the minus st dt. So remember, this right here is the same as the Laplace transform of what? Laplace transform of 1. So I don't need to start going through the previous steps again because I already know what it is. So just the way it is here, okay, just the way it is, I'm going to say this is equals to c multiplied by the Laplace transform of 1. But I know that the Laplace transform of 1 I found that is what? 1 over s. Hence the Laplace transform of c is just equals to c over s, meaning c can be anything. It can even be 1, it can be 2, it can be, it's just a constant. Okay, so that's what we have found there. So what else do we need to find? We also have to find what the Laplace transform of let me say mm, let me say e to the at, meaning a can be anything. It can be negative or positive. It can be any value. Okay. So now we are going to say the Laplace transform of e to the power at, okay, equals to, you are evaluating from 0 to positive infinity, then that would be e to the at here, then multiplied by e to the minus st dt. All right. So here we just have to, we can unite these two. Okay, we can write them together. So this is just going to be uh, that's going to be e to the power at minus st, like that, dt. So let me try to simplify this a little. So this one is going to be 0 infinity there, then 0 here. This is going to be e, so I can factor out the t. um, that's going to be, I can put open bracket, I can put a, okay, a minus s to the t there, okay, dt. So now one thing that I observe here is that if I integrate this one, I'm going to end up with something like e to the power a minus s t divided by a minus s. But remember, you are evaluating from 0 to what? 0 to infinity. Okay, so if you put infinity here, everything's just going to be infinity there. Okay, that's just going to be infinity. So now, for me, to make sure to say what I have here converges, I have to do something with this power that I have here. So instead of writing it like that, I'm going to write it as uh, from 0 to infinity, that's going to be e. So I'm going to put minus here. It's more like I'm going to force the negative out, but remember to say a doesn't have, a is positive. So to maintain the sign of a, this one has to be positive, so that if I say negative times this positive, I have negative s. Then to maintain the positive sign of a, is supposed to be negative a, then t, like that. Okay, dt. So we say this one changes to negative, then we swap these two. That's going to be s minus a, such that if I press infinity here, this will bring me back to me having something like 1 over e to the infinity, which is just 1 over infinity, to give me 0. Okay, so evaluating everything that I have here, okay, evaluating what we have right here. So you observe to say, if you plug in infinity, this is just going to be 0, because this will be 1 over infinity divided by a minus s. That will be 0 divided by a minus s, which is going to be 0. But again, I feel like there's something that I've forgotten here. The denominator needs to change as well. Yeah, so this is supposed to be minus, that's supposed to be minus s, but I'll put the minus here. That would be s minus a, like that. Okay, so this was supposed to be in the bracket like that, then I put negative, but I've just placed it right here. So now when we subtract, when you place infinity, you're going to get 0. When you place 0, this is just going to be, this will be 1. So that would be like minus, okay, the minus from when you are evaluating, then open bracket, minus 1 over s minus a. This is just going to end up to be what? To be 1 over s minus a. So this is what the Laplace transform of this one is, and you might want to have that in mind, because you're going to be using it like a lot. Okay, so some other transforms that we have to that we have to keep in mind are transforms such as t to the n, as well as let's say sine 80, as well as cos 80, even the hyperbolic sine of t, Okay, let me just put AT there. Then also hyperbolic cosine of AT, like that. So um, these I'll try to look at them in the next video. That's what I wanted to look at in this video. These are a bit longer because when you are doing them for the first time, it's quite a long process because I have to use integration by parts, or I can use the Euler equation for some of these, but I'll do that in the next video. So make sure you watch the next video after this one. Thank you very much for watching.